power control can live in any right? We said we'll write a little answer for the power control. We'll start with that. So moving forward. In the past papers they have asked what are the methods of power control. So shall we write little containing power control? This power control in UMP. That's the idea of this power control. When we say first, there are two ideas. First, inner and out. It's better to draw a diagram like this to show the whole thing. Inner and outer are variations used with the first. UMTS this one, OLBC, TLBC. These are main key ideas within the UMTS. This one is partially implemented, not fully. Partially implemented, not completely implemented. Write few short notes in each one. First one is CPC, centralized power control. The power of all U is to be controlled from one central location and a database. Shall we say power of all U is in the RAN, in the radio access network, in the RAN to be controlled. Power of all U is in the radio access network to be controlled from a central location. Then when you centralize all the power control, the disadvantage is you need the centralized power control, additional centralized power control. Right? This needs an additional centralized power controller. Added complexity, that means more complexity, latency means delay, latency, and network vulnerability. vulnerability, vulnerability. Vulnerability means if someone attacks the central database or whatever, then all the power control in the network is lost because everything is happening from one side. If there is a failure or if there is an attack, network will go down. Whole network. So because of those factors, the UMTS, when they implemented, did not implement centralized power control from the MSC level. They gave it to the radio network center. That means RNC. At each RNC it was implemented, not at the MSC. Okay, right? Therefore, it is only implemented at RNC level. Only implemented at RNC level, not at MSC level. Not at the MSC level, in UMTS. Then second one, distributed, DPC, distributed power control. Also called decentralized power control. That you can write power control function is handled independently by BS base station ORNC, within brackets, towards the edge of the network. Not the center, but the edge. Edge means the corner, right? Edge, EDGE, edge of the network. Center means MSC, edge means either the base station or RNC. But there is no central coordination now. Each RNC is independent to handle power control. And for the reaction, this is the method followed in UMTS. This is the method adopted by UMTS. This is the method adopted by UMTS. Because it can respond, these are the advantages now, because it can respond more adaptively to maintain required quality of service, required QoS to the user. To maintain required QoS, full stop, required QoS. Underline respond more adaptively. That is the advantage of distributed system. So if they ask why is the distributed method selected, that is the answer. Because it can respond more adaptively, more quickly, and maintain better quality of service to the user. So central method is having a disadvantage that it can be vulnerable, that means attacked or failure can occur, and also you have to have an additional central controller for this purpose, and that means new protocols are required. Therefore they did not implement that fully. Instead they implemented it at the RF. If you look at the full distributed one, that means power control should be done only by the base station. But UMTS designers thought halfway. Okay, little part of the power control to be done by the base station, more part to be done by the RNC. RNC is not the main center of the network. RLC is the center for few cells control. So within that, power control is centralized, but within the whole network, power control is not centralized. So those are things you must understand, because the question can come in different ways. So understanding is very important. Then this decentralized one, whether it is centralized or decentralized, you can have open loop and closed loop option. So that you can couple, for example, DPC with open loop, or DPC with closed loop, or CPC with open loop, CPC with closed loop. Like that, many combinations are possible. New line. Repeating open loop power control. Open loop power control, OLP. Open loop means open loop means you can send power control commands only this way, no return, no feedback. Normally from RLC to UE or from node B to UE, only this way. If it is inner, it is like this. Outer, it is like you can have inner and outer option. Same way, you can send the power control commands either from here or from there. And UMTS designers have selected this side. This is not popular. It is there, but not very popular. So we do it. Anyway, you can go both, although this one is a popular choice for the way. Now this open loop control happens when the user equipment is idling. It is not transmitting. Is just monitoring the control channel from the network, and by looking at the signal strength of the control channel, it can guess how far away the node B is, and that way it can decide what kind of power is suitable to reach the base station when the need arrives. It may not be transmitting now, but if a call is required to be originated, then it will know with what power it has to try for. Otherwise, what will happen? If it try with the maximum power, during that particular time, all other sets will be cut off. You know, in WCDM, if one set transmits high power, others will be having the nearby effect, and they will all be cut off. So, you can't allow a user equipment to try initially even with maximum power, then others will be affected. So, the initial try is also with the control power, and that is why the open loop is necessary. You can write the UE silently monitor CPICH broadcast channel from the network, when it is in idle mode. When it is in idle mode, and estimate of the received signal strength is used to decide its transmit power. An estimate of the received signal strength is used to decide its transmit power. So, sir, in addition, it receives information about the allowed power parameter from the cell BCCH broadcast control channel when in the idle mode. BCCH is the channel which is going here. CPICH is coming there. Both will be supporting the user equipment to decide with what power level it should initiate communication. And there is a channel called packet random access channel, PRACH. That is the channel it will use to initiate first communication. But even before you start using this channel, you have to estimate how much power to transmit. Otherwise, you will be disturbing everybody at there. Even before you access the random access channel to get access to the network, the user equipment should know all this by monitoring. This one-way community. It is one-way because the user equipment is not saying anything back. That's why we call it open. You can write new paragraph. QE estimate what should be transmit power. To access the network based on access network, based on the above channel. Then it initiates PRACH, packet random access channel, PRACH. With that power, to connect with the network. What are the channels involved? CPICH, BCCH and PRACH. It will be continuously monitoring CPICH and BCCH. Based on the information it decides what power to transmit, then it will initiate PRACH to transmit. So when you dial a number and press the send button, request goes on the PRACH. But it should know what should be the power. And to decide that, it will be using the information of BCCH and CPICH. So that is called open loop. Why do we call it open loop? Because you are silently monitoring this. Only when the user presses send button only you will be transmitting. Till then you continuously monitor and keep guessing what distance you are from the base station. So that's why it's called open loop. But why is open loop not sufficient? While you are in a communication, why is it not sufficient? This is before the communication starts. While you are in the communication, why is it not enough? Can't we use the open loop all the time? We can't, because This is for the initial estimate only, but while you are communicating and moving, your fading characteristics, so multipass continuously change very, very rapidly. And therefore, this command method is not enough. Your phone will have to be given separate power control command from the base station, which is not true for the other phone. It's only for your phone. So that is for inner loop. This one is not enough in order to handle the fading channel when you are communicating. So go to stand. OLPC is not sufficient. OLPC is not sufficient. When UE is communicating, because the fading characteristics of the channel vary very rapidly. Very rapidly. And also independently. Very rapidly and independently for uplink and downlink. For uplink and downlink. If the question asks why is open loop not enough, this is the answer. Fading channel is changing very fast, so open loop is too slow to handle that. So that is why closed loop is also implemented. UMTS has a closed loop as well. So next subheading, closed loop power. CLTC. Now the need for that is very quick response to power control requirements. Closed loop is there to dynamically adjust the power while you are communicating. So that function, this is needed to handle the fading channel characteristics. Needed to handle fading channel characteristics. Using the signal coming in, you have to calculate pilot strength. From the downlink, you will calculate the pilot signal level strength. You may remember the time diagram I gave you earlier, there was a pilot channel. So using that, you calculate the strength. Then your transmit power is proportional to 1 over this value. That's the this. So if you receive less pilot signal strength, your transmit power will be high, because that means you are far away. So your channel is fading. So that's the basic idea. Inner loop means there will be power control commands from node B and replies from B. In the TPC command, transmission power control command. And response. So that's the inner loop. Outer loop is maintained between these. TPC commands are coming from there. Responses go up to there. Control the two loops, inner loop and outer loop. Inner loop is called the fast power control. Outer loop is called the slower power control, slow power control. Continuous control is maintained, otherwise some other party will be affected due to your community. So mention that 1500, then you can see how fast it is happening. And also remember, it happens both ways, uplink power control as well as downlink power. Uplink power control is the most important. This is uplink. Uplink power control is more important, but downlink power control also happens through the same communication. Downlink means the user equipment is telling the node B to adjust the power. Uplink means the node B is asking the user equipment to adjust this transmission. Both are happening. But uplink is the most critical. Why do we need downlink power control? Uplink we all know, near far effect. Downlink, if you don't control the power in the downlink, base station will be transmitting too high power and will interfere with the adjacent base station. Because adjacent base station is also on the same frequency, remember. So you must transmit only the necessary power for your customer. But it is not that critical because it's only raising the interference level. Uplink is very critical because some people will be cut off if some user equipment transmits higher power than necessary. Okay. You can make that. Both loops operate simultaneously. Both loops operate simultaneously. Note that the inner loop has very fast rate of sending TPC command. Very fast rate of sending transmission power control command. Uplink power control is very critical. Downlink power control is used to limit the Tx power of node B, Tx powers of each node B in order to minimize the interference with adjacent node B. With adjacent node B. Outer CLPC, outer closed loop power control, outer CLPC is mainly useful for macro diversity. Action. Macro diversity we have in the node. Okay. So those are the ideas. Essentially 1 dB, 2 dB, 3 dB step. So TPC command will say, okay, go up by 1 dB or go up by 2 dB. These are the 3 steps commanded by the tester. User equipment is also commanding the node B, can you reduce the power? I don't need this much of power. Kind of, okay. So node B will analyze and reduce the power just sufficient to maintain communication with its customer. Otherwise, it can interfere with the adjacent. So these are all power control techniques in the UMP. They are all being used at one moment of time. And you know the reason. Suppose they ask you what is the main requirement of power control in UMP, especially the uplink. What is the keyword you must have in your answer? What effect? Near far problem. So near far problem, that near far effect, never miss that it is a keyword. Right? Near far effect is not there in other systems. WCDMA has that particular problem. So that is the keyword in the answer. If you like, put a sign. Main reason for power control in WCDMA. Main reason for power control, uplink power control in WCDMA is to minimize the near far effect. Minimize the near far effect in CDMA system. So underline that, because don't miss that keyword when you are talking about power control. Because in CDMA that problem is not there. So your answer should have this as the main. In addition, you can say fading characteristics, interference, and other things are there. You are trying to minimize them as well. But this is the main problem. And if they ask why the inner loop has to operate so fast compared to GSM, this is the reason again. Otherwise, the near far effect can, from time to time, affect the other users due to your communication. So again, the near far effect should come in the answer.
Downlink command.
No, this one is very much slower. It is about twice a minute time. Very slow. Because this one is not mainly for that adaptive power control. It is mainly to have the macro diversity situations only.
No, that downlink in the upper one.
The rates are coming at 1500. It's a constant, but some of the commands are for the downlink, some of the commands are for the uplink. Within this way. this is not only for the downlink, right? Not only for the uplink or downlink, it's for both. CPC channel is operating at 1500, and within that, some commands are for the uplink control, some commands are for the downlink control, and mostly it is for the uplink control.
CDM downlink time division multiplex
downlink
की यार power control information EDM multiplex करने वाले अपने के code division multiplex करने
that reason I have given in the answer itself, not itself, that those little clicks we hear, it is there if you read the answer. Now one question they normally ask is why do we use CDMA in uplink, right? CDMA in the downlink, and when you read my notes you will find the answer there, because if you use the CDMA with the user equipment, then there are little clicks heard every 10 milliseconds you are changing the field. So your field changes will not be heard if you use CDMA. Can we go back to that? I remember you. So that's one of the important things.
So the base station is even a voice
No, from the base station it won't be a problem, because it's not the battery powered one. Battery powered one is the issue. Because in the battery power, when you try to change the field, there is a power level adjustment. Power level automatically changes. So why don't we look at that whole knot? It's there. Shall we look at next? I think that part we'll have to remember as it is, because I have carefully planned that note to answer this question.
But I don't have a problem with battery power.
I think it should have been mentioned.
අනිත් එක කියලා දිනවා අර 1500 rate එකේ යනකොට click time වගේ ඒක තියෙනවා battery power එක හින්දා ඒ problem එක වෙනවා කියලා U එකට විතරක් වෙනවා කියන්නේ
one side it is battery operated, other one is not battery operated, that is why it is planned. What are the two channels we multiplex? We multiplex CPCCH and CPDCH. Okay? And those two in one link you will find is CDMA, other one CDM, other one TDM. So that is the question. Why is CDM used in one direction? Why is CDM used in the other? Yeah, that's also they are mentioned in the typing I gave. Downlink is common to everyone. This one? No, this is not common to all. This is also specific to the particular usage. This is not common. What is common is not this one. What is common is open loop. Open loop is common to everybody. Closed loop is not common to everybody. All closed loop commands are specific to that particular segment. And that is why the two have to be differentiated. Open loop means you send to everybody and you don't expect an answer from anybody. Closed loop means you specifically send the command to him and he will respond to me. Okay, I adjust it.
According to one usage equipment, but we can't use the power have other.
Yeah, in the uplink, the most critical one is uplink power control. Individual user equipment will have that. Downlink power control, many user equipment like this will be telling the node B, I don't need this much power and things like that. It will be telling that node B will have to analyze the weakest one and then plan for that. Downlink will not be adjusted for every user equipment. It will be a common average value. It will calculate and adjust accordingly. Suppose there is no user saying, suppose everybody says it's too much for me, then you can reduce. So that is the idea. So with that I think we can answer our control. Maybe this is the missing part in the note. The other things are there in the note. Why CDM, those things we have decided. Okay. Well, what are the other things? Now I hope you have crammed quite a lot of Lot of notes, right?
So FM වලදී අර second IF frequency එක 10.7 නේ. ඒක first එක මොකද?
In the FM, first one is 10.7, second IF is 455. No, second one is not 10.7. FM receivers, first IF is 10.7, second IF is 455.
So ඒකට AM වල ඉන්නේ second one 455 අරක 10.7.
AM you don't need 2 IF. AM is normally 1.
So double super heterodyne.
AM double super heterodyne 455. I don't remember the other.
So again IF frequency 455 ගත්තා කියලා FM white band signal එකේ effect එක නේ quality එක loss වෙනවා.
When you
මොකද
take
දැන් AM වලත් 455 ගන්නවනේ IF එකට. FM වලත් ඒකම select කරලා තියෙනවා. එතකොට මේ ඒ කියන්නේ අරකේ white band signal එකේ quality එක loss වෙන්නේ නැහැ නේ. මේ
no, bandwidth is center frequency is 455. Bandwidth if it is AM it will be a narrow band one, FM it will be a wide. Quality depends on that. Center one is 450. FM needs a wider band around 455. AM needs a narrow band around 450. But 455 is there. You can read.
ඒක දෙකක් තියෙනවා XLR කියලා එකක් තියෙනවා DLR කියලා එකක් තියෙනවා ඒ දෙකම අහන්න අහන්න ඕන ඒක අහන්න ඕන මෙන්න මේකත් අහුවත් තමයි මේක ඩිස්කස් කරනවා කරන්නේ ඒක කරාට මේක threshold level ගන්න විදිහට
So 1 year there was to explain the effect of this power control on the frequency reuse factor, which is what I mentioned as downlink power control. If you don't control the power in the downlink, then the frequency reuse in the next adjacent cell cannot use the same frequency, because you will be transferring too high power and interfering with that. Actually, it is the same thing. They have asked in a different way. So if they ask why do we need downlink power control, still the same answer. Or they may ask it that way. What is the effect of power control on the frequency reuse? Again same answer. Frequency reuse means can we reuse the same frequency in the other adjacent cells? The only way you can reuse is to have downlink power control. Otherwise you will be transferring too high power and interfering. Two different ways of asking the question, but same answer. Answer is different.
ඩිප්ලෝමා කරපු ආන්සර් එකක් වගේ ගන්න තියෙනවා FDMA TDMA සැටලයිට් එක. ඒ කියන්නේ එක ෆ්‍රීකවන්සි එකේ ටයිම් ස්ලොට් බෙදලා තියෙන එකයි එහෙම ආන්සර් එකක් තියෙනවා.
Consider this question number 10 of 2006 December. He is asking about SATCOM, but it is saying following access methods to describe in SATCOM. Number 1 is FDMA, number 2 is CDMA. You can give an answer close to what we discussed in the diploma, but it's better to modify it slightly for SATCOM. I will highlight that. Right? Theory is the same, but some practical details you can include in your answer. FDMA means when you discuss FDMA as the basic FDMA theory, after that you can just mention. If the satellite system balance is like this, you will subdivide it into frequency bands. not be equal in that. Subdivisions need not be equal. That is a specialty when you describe. And in the theory we studied in diploma, we said we divide the frequencies equally for different users. When it has some different stations which are allocated different bandwidth, so they are required. Like ABCD could be different stations. And another specialty is there are guard bands between them. You can mention ABCD or Earth station. ABCD or Earth station. Allocated bandwidth need not be same for all aspects. Allocated bandwidth need not be equal. It depends on their requirement. Allocated bandwidth need not be equal, and it depends on their requirement. That's one point. Second point is guard band should be allocated, should be left between adjacent aspects. Guard band should be left between adjacent aspects. Adjacent aspects. This is to minimize interference from each other. Minimize interference from each other. This is the minimum frequency of the satellite band, maximum frequency of the satellite band. Frequency division, because different frequencies are allocated for different station traffic. Why you can further explain why it is FDMA, and you can do that part. Now the spectrum has been divided in frequency. Then each frequency portion is allocated to one aspect. That's why the name FDMA. So that's what you can write with. It is normal as diploma. Frequency spectrum is divided to different portions. Each portion is assigned to one station, and all of them can transmit simultaneously. All of them can transmit simultaneously. You can write those things very quickly. They are basic. What about the receiving? We talked about transmitting, receiving. Suppose you are terminal, you are station A. What part would you receive? Only this part? This part actually you need not receive, right? See something, you transmitted, so you already know what is there. So you should receive the whole spectrum and take the parts from other stations by naming this part. And when you take station B, he might have a little part for A, another part for C, another part for D. This is station D. So when you are receiving, you have to take only this part. So it's coming to you from B. Suppose you are A, this is the part coming to you from B. Other parts are not for you. So therefore, when you are receiving, every application receives the whole satellite spectrum, satellite band. And after that, sort out what are the parts coming to it from other space. But when you are transmitting, you are not transmitting the whole satellite band. You are transmitting only your band. When you are receiving the whole bandwidth and then sorting out what is for you. Please. So can you mention that, please? When transmitting, each station uplink only the portion of the spectrum assigned to it. Only the portion of the spectrum assigned to it. Assigned to it. So when receiving, each station should receive. Each station should receive the whole system band, whole satellite system band. Then it uses filters to extract extract its own traffic. To extract its own traffic from others' transmission. To extract its own traffic from others' transmission. Okay, so those are the key things you should have in your answer.
So මේ කියන්නේ අර uplink downlink කියලා GSM වගේ වෙනම test දෙකක් බෙදලා නැහැ. එකම මේකේ ඉන්නවා. ඒකනේ.
Uplink is divided, downlink is not divided. Downlink means you have to receive everything and then you have to sort out the sub channels for you. Uplink is divided like then TDM time division multiple access means you have a frame. Guard time. Earlier they had guard time, now guard time. And then these are time sort of phase. Time sort of phase. In satellite locations can transmit to the satellite. Take one satellite transmission, can be further. every station will be transmitting 6 cycles. P times PM. P4 control and timing. Then key points you can mention one under the other, like all stations transmit on same frequency. All stations transmit on same frequency. All stations transmit on same frequency. Second point. Each can use only its own time slot. Each can use only its own time slot for transmitting. Only its own time slot for transmitting. But it will receive the whole frame. It will receive the whole frame. Transmit will be only your time slot, but reception you can receive the whole frame because there will be traffic for you from the other. So while transmitting only your time slot, receiving everything. Like in the FDMA. In FDMA, when you are transmitting only your frequency band, when you are receiving, you receive all frequency. Same idea here. Okay. Next point. Guard time should be there. Guard time should be there. Between time slots. To avoid overlap due to timing error. Overlap due to timing error of first station. Timing errors of first station. Suppose some station transmit little late or little early, then it will corrupt the other one. So that's why the guard time should be. It is very important in that form. Without guard times, you will always damage because these are from very far away. These different stations, and for them to time their transmission exactly is very difficult. To make the matters worse, the satellite is also moving relatively with respect to Earth station. So there will be anyway slight change in the timing of the arrival. So those are the important points. Other than that, it is like normal TDM, except the guard times. Guard times were not there in the normal E1 kind of lines. You didn't put a guard time. But why is E1 not having guard times, but this is having? E1, all the channels are sampled by one clock. So you don't have clock problems between them. Therefore, one byte will be closely fitted with the next byte. Right? But here each station is using a different clock, and they are far away from each other. Therefore, always there are timings. That's why you need to guard time. So one question they might ask is, why do you need guard time? You must mention. This is asynchronous to some extent because each station can have timing problems and timing variations. Other than that, rest is normal TDM. So you can mix these ideas with your normal FDM TDM knowledge, and then you can answer. If they ask an advantage of TDMA in SATCOM compared to FDMA, there is one main advantage. The advantage of TDMA is every earth station can transmit full power. In FDMA you can't, because all earth stations are simultaneously transmitting to the satellite. Each one will have to back off from the maximum. Otherwise they will mix their frequency still mixed in an unwanted manner. But in TDMA, only one station is transmitting at a time. All others are not transmitting during that time. So you can use the full power to transmit. That is the main advantage. So downlink will be more powerful in TDMA than in FDM. So you can put a stand in. If you have to compare FDMA systems have more intermodulation products. FDMA systems have more intermodulation products. IMP, within brackets, IMP, due to multi-carrier transmission. Due to multi-carriers arriving. The satellite, multi-carriers arriving at the satellite. Therefore, they operate with backward. What is backward? Backward means lower power than maximum. You are backing off. Backing off means you don't transmit the full power. Operate with backward. You can underline that word. That's a standard word people use in SATCOM. Backward. New paragraph. But in TDMA, only one station transmits at a time. Therefore, it can use full power, full saturation power. Without forcing IMP, without forcing intermodulation product. That's the main advantage of TDMA. Main disadvantage of TDMA is you need the timing now. Network timing must be maintained. Synchronization is the main disadvantage. Right, disadvantage of TDMA. The network synchronization is required. With the satellite clock. With the satellite timing. And the line network synchronization. That's the difficult part. The advantage is you can transmit saturation power, full power. Disadvantage is you have additional trouble of synchronizing the network to this timing diagram. So in case they ask for a comparison, you can use the idea. Any other? But it's a good question we discussed. Otherwise, that diploma knowledge may not be enough to answer. Any other question? What is it? 2005 June question 6. June question 3. Using typical numerical examples, explain why the dual conversion superheterodyne process is normally used for communication receivers on the HF band and above. 10 marks. That means you'll have to explain the dual conversion superheterodyne block diagram also. And this, at the same, now block diagram part you can get from the notes. Is it there sufficiently in the note? So block diagram I hope you can follow from the note, but in addition you have to include here why communication receivers on the HF bands and above need this. So what is the reason? In fact, you have to explain the reason why dual conversion is necessary.
The target frequency is very high. Therefore, if we choose, you can use IF frequency to achieve both that.
Two keywords are there. What are the two things we are trying to balance? Two keywords.
Image
channel rejection is one. Adjacent channel rejection is the other. So don't forget to put those keywords. Then you have to say, if you choose a high intermediate frequency value, write like this. Assume that you are using single conversion. Then, if you use a high intermediate frequency value, your image channel rejection will become better. Adjacent channel rejection will become poor. Right? High intermediate frequency value means you can't make sharp filters. Therefore, adjacent channel rejection will become poor. But image channel is 2IF away from the main channel. Therefore, image channel rejection automatically becomes better. On the other hand, if you use a too low IF, these two will interchange. Right? Image channel becomes worse because image is now closer to the main channel. But adjacent channel can be sharply filtered because IF is low now. Low frequency filters are good. So that's the argument. Therefore, you find it is difficult to balance these two requirements by choosing one single middle value for HF and above. When you take HF and above, the middle values you can choose are neither fitting adjacent channel requirement or fitting the image channel requirement. So what is the solution? Solution is to have two IF. First IF specializing in rejecting image channel. Second IF specializing in rejecting adjacent. Those are the things which must come in the other than what is there in the note. Right? Because it's 10 marks, it's better to write all that in the note as well. Plus this argument I just made. Keywords don't miss adjacent channel rejection and image channel rejection. Don't miss those keywords. That you can manage it. Should we write an answer or explain everything? If we write, you will have to try. If you don't write and you keep the idea, maybe it is easier for the head. I think by now you have identified your key strengths. Some of you have what we call photographic memory. How many of you have photographic memory if you have identified? No? That means you have not identified. Definitely some of us have photographic memory. And shall I ask this way, how many of you can remember the map of your home, where the rooms are and everything? Suppose you have visited National Museum once, right? How many of you can remember how to go there and what are the rooms there, main roads? If you can remember like that, that means you have a photographic memory. It's very important you understand your strength. Some have, some don't have. Some, even if you take him for the second time there, he won't recognize that he was there earlier. And they are not having photographic memory, but it's okay, right? It's quite okay, right? Because there are other ways we remember. Everyone has a different way of remembering. If you have a photographic memory, what should you do? How do you plan? You have to make sure your note is complete and well written, because you tend to remember the block diagram passively. You tend to remember where the note is. Sometimes when a question is asked, you remember, okay, it came like this, I had underlined it there. It comes into your mind as a picture. And for them, questions, descriptive questions are normally easy for that kind of paper. But some of you will never remember the note. Will never remember the note. Will never remember where it was. then you should not try that. If you try to remember all that, you are trying to use a capability which you don't have, and you will be in real trouble after that. And some of you will not remember the note or the order of the note or anything, but you are very strong in remembering the idea. Idea means, of course, adjacent channel rejection means this, image channel rejection means this, but you may not remember how the note described all that. That's fine. That's another way. For them, cramming by reading the book is not recommended. They have to write. They have to keep thinking, writing, and then throw away the paper. Again write, throw away the paper. That is the technique for those people. So if you have not understood your strength, do it very quickly. Even may not be before the exam, but someday you have to do it. Someday you have to do it. So each person has his own way of, strong way of handling the situation. Each one has. Everyone in the world is gifted with some strong technique, isn't it? Some technique which is strong. For example, even if you take a blind person, he is very strong in listening to very distant sounds sometimes. Very strong in imaginations, like how to imagine the surroundings. If you have worked with blind people, you will realize. I worked with blind people some time back to develop a stick for them, electronic stick with the students. Then I realized how strong their perceptions are. They can see much more than we see. You have to work with them to realize. Because they visualize everything. They have no photographic memory because they have not seen anything. No photographic memory. But they are very strong in ideas. They can remember the concept very well. So likewise, each one of you has a key strength somewhere. Some way of remembering. Everybody remembers something. Everybody remembers something. And you have to identify what is the way I remember best. And develop it. That is the way, that is the trick to answer all this. So if you don't have photographic memory, don't try to remember the pages of the book. You will never be able. Instead, try to concentrate on these ideas, keywords, etc. Write them down and solve it. So you can't remember the pages, don't keep the pages. But those people who can remember the pages, remember the page as a photograph, you should write your answer, well-written answer in one place and try to remember that. Try to cram that even, because your strength is remembering that. Okay. But if you have not consciously thought about this, you will think, okay, I don't have any of that. That's the way some people think. Some people think I have no photographic memory, I have no conceptual memory. Conceptual is other time. I have no conceptual memory, then I have no sound memory. Some people have sound memory. They remember what I said rather than what they wrote on the book. So if you don't investigate this, you will think, okay, I don't have any memory. I am getting loaded with a lot of notes and everything, and it's difficult for me. But that is wrong. Everybody is gifted with something. Maybe you did not realize that. So if you got low marks in radio subject, say in the diploma, go for the reason. Why did it happen? What is the method I used to remember? Okay, then you will find the way. Everybody has a way. What I am saying is everybody has a way. It is your capability to unearth that secret for you. These conceptual techniques, photographic techniques are standard ways of cramming. Standard ways of cramming. Effective length and effective effort. Okay. Effective length means suppose we take a equal kind of thing. Physical length is the measured length here. It is called L physical. Electrical effective length is total damage. This is that is the length which will be used actually to collect energy, because there will be energy distortions at the edges. So effective length divided by physical length is known as efficiency of the air. So those are the things we have to write. Maybe we can write. It's in the diploma note, but anyway we will write. Can you write? Effective length of energy. You can write electrically effective length of an antenna. Electrically effective length of an antenna is the length which apparently seems to participate in collecting energy from the incoming electromagnetic wave. If capital E equals tangential electric field. Capital E equals tangential electric field strength. Electric field strength to antenna conductor. Tangential electric field strength to antenna conductor induced voltage, terminal voltage of the antenna will be electric field strength, which will be in volts per meter, multiplied by effective length in meters. Therefore, effective length will be, volts per meter multiplied by meters will give you volts. Therefore, effective length will be terminal voltage divided by electric field intensity. This is how to calculate. Terminal voltage of the antenna you divide by the field intensity. Also you can mention effective length divided by physical length is equal to antenna efficiency. Ratio is antenna. Reason you can mention. Reason why effective length is short. Reason is that the current distribution along the conductor is not uniform. But becomes less and less at the edge of the conductor, at the end of the conductor. Less and less at the end of the conductor. Give an example of a dipole. Dipole current distribution is like this. Maximum current is minimum current is at the zero. So because current distribution is not equal everywhere, these edges have less participation in getting electric field converted to voltage. That is why the edges are not very effective. They have to be left out in the calculation. Edges have to be left out because their currents are very low. So if they ask you to explain the reason, this is the reason. Non-uniform distribution of the current along the conductor. If there is a uniform distribution, physical length and effective length will be same. Due to non-uniform distribution, physical length will be less than the electrical effective length. Okay. So again, if you are capable of remembering the concept, don't remember the diagram, remember the concept. If you are capable of remembering the diagrams, then draw it and have an answer and take a picture of that into your memory. That's photographic memory. Okay?
So effective aperture කියන එකත් මේ වගේ diagram එකක් තියෙනවා.
Effective aperture is very similar, except that this length will be area. A effective. This will not be a terminal. This is power density. This is power received. Not voltage, but power received. Power received will be power density multiplied by the effective aperture. So, similarly, this is effective aperture. This is DR divided by power density. And physical aperture, effective aperture or physical aperture is antenna aperture efficiency. Again, what is the reason? Reason is when you take the antenna like a dish, for example, power coming at the edges will be leaking light. Power will be leaking from the edges. So edge area you are not taking into your effective calculation. This is due to diffraction. Diffraction means energy coming to a corner like thing will be escaping the corner to the other side rather than focusing to the center. Other energy will be focusing to the center. Edges will not focus. So that way you have to rearrange the same answer. Can you quickly write this? Finish that up. Some other years effective aperture, same thing but readjust. Most of this is from the diploma radio antenna part. Take that one. December 6 Question 6 part B, 7 December. Using suitable values for data fixed rate, shift rate and acceptable power density to interference ratio, explain how a WCDMA system can operate with a carrier to interference ratio well below 0. I think we did last time. We wrote that. What do you mean? Answer is there. If you miss the revision class, please catch up, because revision is very important for the exam. Right? Don't go to the exam without making sure that you knew everything we discussed in the revision. So revision is for the exam. Note is for your career. Note is for the career. Revision is for the exam. Question 2 part C, 2006 June. 2006 June, question 2 part C. Describe one method of determining the value of antenna gain when the antenna is used as a transmitting element. Okay. Antenna is used as a transmitting element, and what is the gain?
2006 June 240.
As in the trick here is that they have mentioned antenna is being used as a transmitting element. That means you can't disconnect it from the transmitter. It looks like, right? But otherwise, I'll give both methods. Otherwise, there is a more simple way. But when it is being used as a transmitter, if you are unable to remove it, then you have to go and take a lot of measurements around the antenna, right? And that's a bit difficult, right? So we will do it like this. Only one or two instances, this is running maybe 5. So these angles we will have to measure and project, and after that we will have to take it could be any receiving antenna, it doesn't matter which one. Normally and only one is this one. A circle like on a certain distance, it should not be very small distance, let us say R. Then you may take your receiver to this place. And you have to do it right now. And then note down the reading of the receiver here. So let us draw the receiving antenna here. Similarly, you have to move the receiver in all places, note down the reading, and then come. Draw the radius R. What do they ask? Is it calculate the gain or draw the radiation pattern?
Describe one method of determining the value of antenna gain.
Value of antenna gain, not the pattern. Okay? When you determine the value of the gain at a particular point, say A, you have to first, you normally use something like a dipole here. You take the reading and then convert the dipole to omnidirectional value by using a conversion factor. So we will mention there. If antenna is in operation, antenna is in operation, and cannot be removed, then we should identify suitable far field radius. Suitable far field, FAR, far field means fair distance away, you can measure very close. Far field radius, capital R, and identify point as shown in the above figure, point A, B, C, etc. Point A, B, C, etc. as shown in the above figure. Point A, B, C, etc. as shown in the above figure. So, new paragraph. Then use a vertical dipole and connect it to the receiving end. And take RSSI reading. Take RSSI reading. RSSI means received signal strength identification. Indicator. Receiving signal strength indicator. RSSI reading. Then convert it to dBi value, dB isotropic, dBi. Mention that reading is dBd. dBd means dB over dipole because you are using a dipole. D for dipole. But dipole gain is L of 1.64. L of 1.64 dB. 1.64 is the gain of the dipole. You take L of converting to dB ratio. When you calculate dBi value, take the dBd value, subtract this L of 1.2. So dipole has more gain than the isotropic. This much of gain additional than the isotropic. So you have to subtract that to convert it to isotropic gain. So subtract that and then automatically you are getting the gain of an isotope. So then correct all the readings according to that and get the maximum. Can write correct all readings using above equation. Identify the maximum rate. Identify the place of the maximum rate. Value of the maximum rate. So that maximum reading is your gain. Right? But if the antenna is not transmitting, but supposing that antenna is available in with you, but it is not connected anywhere, then you won't use it to transmit, you will use it to receive it. So we know that as well. This is not part of the answer to that question, but the correct way of doing it. Correct way of doing it is you take a transmitter and this is you want to in the place where you see the antenna. You want to test. This one is the standard dipole. Remember, this is the correct way. The earlier one is a special case where they say it is antenna is transmitting, then you can't remove it. Correct way is you will have an axis. Line is with this antenna and take the reading. And after that, this antenna is normally mounted on a rotary platform. Yeah, all these readings, 10 degree, 15 degree, they are already marked. Rotary platform, this is 0 degree, this may be 5, 10, like that. So, what you do is you make it 0 degree, note down the radius. Then turn to 5 degrees, antenna is rotated 5 degrees and note down the reading again. 10 degrees, note down the reading again. 15 degrees, note down the reading. Then you get a full set of readings in the 360 degrees. And that way you can get the full polar of your antenna. And this one you don't move. Transmitting antenna you don't move. Receiving antenna you keep rotating. That's the standard. Then you don't need large radius or anything, right? You will be just selecting 2 points, mounting one of the antennas on that rotary platform, and then keep changing them. It is normally calibrated. Keep it 5 degrees by 5 degrees and keep note down the radius. And after that plug. You can write that. This is the correct way, remember. Keep the transmitting antenna fixed. Keep the transmitting antenna fixed. Switch up. At a suitable distance capital R. Suitable distance capital R. Mount the antenna to be tested. On a tripod, TRIPOD tripod with a rotary platform at the top. Rotary calibrated platform. Rotary calibrated platform at the top. Then at every 5 degree rotation of receive antenna, down the reading. Note down the reading. Compare. Note down the reading. Plus, what is reading against the angle? What is reading against the angle? On a polar diagram. New paragraph. To calculate the maximum gain, maximum directive gain, locate the maximum reading. Locate the maximum reading from the plot. Then remove the antenna. Remove the antenna under test. Remove the antenna under test. Remove the antenna under test and mount a dipole. Mount a dipole on that platform. And note down the reading. Note down the dipole reading at that angle. Note down the dipole reading at that angle. Now dBi equal to dBd value gain over the dipole. Now 1.6. dBd value is gain over dipole. How do you measure the gain over dipole? It is reading of antenna and rotate antenna being tested divided by the reading of the dipole. dB over dipole. What does that mean? If your reference is a dipole, how much above is your antenna with respect to that dipole? So you take the reading which came from your antenna, divide by the reading which came from the dipole. Then you get the gain over dipole. But you know dipole also has this much of gain. Therefore, add that to the reading, that will be the correct reading for your antenna. This is the directive gain of the antenna. That means you use the dipole, measure the gain above that, and add the gain of the dipole to your answer. That will give you the correct gain of your testing answer. Why don't we use the isotropic radiator? Why do we use the dipole to do the measurement? Simple answer. Isotropic radiators cannot be found anywhere in the world. You can buy them from the market. Dipoles you can. So that is the reason. We have a short break.